Okay, so here, let's do some other ones actually. Oh, so these actually, I was gonna have everyone try on their own now. Take about 5 minutes. Okay. So again, for these three, what we're gonna do is factor. Okay. So for the first one, again, we want for each of the, oh, sorry, wrong button. For each of them, right? We want two numbers. Make sure you guys can hear me, so good, okay. We want two numbers, right? Whose product is the constant term and whose sum is the coefficient of x. That capital B. So here we want two numbers whose product is 40 and whose sum is 14. So yes, 10 and 4 are going to work. Their product is 40 and their sum is 14. So these two numbers are going to work. So because of that, we get this. We get x squared plus 14x plus 40 is x plus 10 times x plus 4. Okay. So again, here I did a check just to make sure, and this is what we get. Okay, good. So that's one example. For the second one, right, it's a little bit different, not much. We have 40 and 13 now. So of course, 10 and 4 would not work, right? Because we want two numbers here whose product is 40 and whose sum is 13. So 10 and 4 would not work. However, we do have 8 and 5, as you can see here. For 8 and 5, we know their product is 40, their sum is 13, so these are the two numbers that are going to work. It might take a few tries to get the two numbers. That can happen. But if that happens, don't give up, okay? But 8 and 5 are going to work, and as you can see, those are the numbers that work. Okay, that's good, that's good. Now I said the last one was a little tricky, right? May I actually go back to it? No, let me just keep on. For the last one, right, we want two numbers whose product is 20. The sum is negative 13. Okay? So what I did was I tried different numbers. Okay, what about 10 and 2? That's not going to work, right? Because 10 times 2 is 20, but the sum is 12, not negative 13. Same thing with 5 and 4. The product is 20, but the sum is not negative 13. If you were to actually go through all the possible pairs of numbers whose product is 20, it turns out none of them are going to work. None of them would work. So in fact, this one cannot be factored. This cannot be factored. So again, you're looking for all pairs of integers whose product is 20, but you want the sum to equal negative 13. But again, none of the pairs are going to work. There are no two numbers. So this cannot be factored. Are there any questions on this? Okay. Well, here are just some formulas that can help as well. Again, we have seen some of the formulas before. From the formulas, you can actually factor certain polynomials. For instance, remember one formula we saw was a difference of two perfect squares, x squared minus b squared. But you can factor that because you can write it as this. You can write it like this. Okay? But we can use that because, for instance, what if we had something like x squared minus 9? Well, 9, right, b squared is a perfect square. A perfect square is a number that's equal to another integer squared. So 9 is equal to 3 squared. So we have x squared minus 9, which is x squared minus 3 squared. So we get x minus 3 times x plus 3. Again, it has to be x squared minus a perfect square, a number in this form, where b is an integer. And 9 is like that. 9 is 3 squared. So we get x minus 3 times x plus 3. Here, we have x squared minus 36. Is 36 in this form? Yeah, 36 is 6 squared. So we have x squared minus 6 squared, which is x minus 6 times x plus 6. Now, if instead of subtraction, if we had a sum, then this cannot be factored. Mostly because we're not dealing with complex numbers. But this cannot be factored. So that's good. Okay. So I was thinking about doing some backup examples, but I think people might prefer to try the worksheet. So what I'm going to do, I did email everyone the worksheet. So I'm going to post it now as well. So I think it'd be good if everyone worked on the worksheet a bit. Let me just stop. Let me do that. Unless, yeah, let me check actually. Okay. We just do this just to be on the safe side. I can't see your faces. So, do you want me to go through some more backup examples before I let you try the worksheet? Okay, some said yes, some said no. I thought it'd be no unanimously, but that's okay. Okay. Okay, let me do that then. Okay. All right, so let me do some more examples. Okay, I don't think these are in your notes. Originally, I was going to have everyone try these out as well, but I really want to go through these, so let's do that. Let me delete this slide. Okay, again, I will post a full set of notes. So for this one, right? So this one, let's say we want to factor now x squared plus 17 times x plus 60. So we want to factor that, okay? So again, we want to find two numbers, right, whose product is 60 and whose sum is 17. I don't know why these are 30 and 2. Let me just fix that. Okay. That's what we want to do. Okay. Now the question is that going to work? Well, unfortunately, 30 and 2 are not going to work. Now, why is that? Because 30 times 2 is 60, but 30 plus 2 is definitely not 17. So those two numbers are not going to work. What about 12 and 5? Well, come on. There we go. What about 12 and 5? This should be 16 and 17. I don't know what happened. Oh boy, that's all right. Anyway, well, 12 and 5 are going to work. 12 times 5 by direct calculation is 60, excuse me. 12 plus 5 is 17. So 12 and 5 are the numbers that will work. Again, it might take a few tries to figure out what the numbers are. I mean, you could have tried also 10 and 6, right? But that also would not have worked. So 12 and 5 are going to work. So again, we have 12 and 5, so we can factor it. And we check as well, just to see if we're doing this right. Okay. Are there any questions on this? So here's another one. Now we have x squared plus 12x plus 36. X squared plus 12x plus 36. Okay, so again, we want two numbers whose product is 36 and whose sum is 12. What two numbers are going to do that? Well, the answer's here already, but hopefully you can see that it's going to be 6 times 6. I mean, 36 we know is 6 squared, and 6 plus 6 is 12. So that's going to work. Yeah?
So basically what you're looking for here is like two numbers that multiply 36 and then two numbers that add up to 12.
It has to be
Like
the same two numbers, yeah.
Example. Okay, thank you.
Okay, you're welcome. Okay, so that's what we get here. That is what we get. Okay. Well, instead of 60, this should be 36. So I just fix that. There we go. But that's what we're looking for. Okay. So that is what we get there, right? Again, right, that's what we want, two numbers. So here, as you can see, it does work, right? Basically, what you can do is you can check your answer, right? Again, you want two numbers whose product is 36, the constant term, and whose sum is 12, the coefficient of x. And that's what's happening here. Okay. Good question. Any other questions? Because we could check our answer, and that's what we do here. Okay, I mean, for this technique, there's not much more to it than that. But again, I like to have everyone try out examples. So I figured what I do now is give a worksheet. Again, it's not the hand in, so, it's not, for graded or anything. But there is a worksheet. I did try emailing everyone. It's also posted in week 3 on Blackboard. Kara, did you have a question or?
Oh, no, sorry. My hand was still raised.
Oh, that's okay. That's okay. That's okay. No worries.
Right, thank you.
You're welcome. All right. So what I figured it'd be good to do now is for everyone to work on the worksheet. So let me share that. I mean, we will learn more techniques for factoring as well. Okay. All right, so here, we have a few polynomials, okay? And again, what I want you to do is to factor them. Some of these, though, you have to take out the GCF first. In particular, 4, 5, and 6. You have to find the GCF and factor it out first, not 1, 2, and 3, though. Okay? So I guess what we could do is work on it for like 10 minutes, get as far as you can, and then we'll go through it together. I will post solutions to it as well. So let's do that now.